Hi everyone, my name is Aishwarya and this is my final project presentation for Modern Biomedical Technologies. In this project, I designed and developed an ergonomic key holder specifically for individuals with CMC osteoarthritis. In this presentation, I'll begin by explaining the background of thumb CMC osteoarthritis and why it is a significant problem. Then I'll discuss the motivation behind this project and why current solutions are not sufficient. After that, I'll walk through the design concept and biomechanical reasoning behind it. I will then present the CAD model and the physical prototype, followed by the results and comparison with the existing solution. And finally, I'll conclude with key takeaways and potential future improvements. The carpometacarpal joint is located at the base of the thumb, where it connects to the wrist. This joint is highly important because it allows for a wide range of thumb movements, especially pinching and gripping. In osteoarthritis, the cartilage in this joint gradually wears down, which leads to pain, inflammation, and reduced mobility. As a result, patients experience difficulty performing everyday tasks that require grip, strength, or rotation, such as opening jars, turning doorknobs, or using keys. This condition is very common and has a significant impact on daily life. Studies show that a large percentage of adults, especially women over 30, are affected by hand osteoarthritis. Among different types of hand arthritis, CMC osteoarthritis is considered one of the most functionally limiting because it directly affects thumb usage. Since the thumb contributes to a majority of hand function, even simple tasks can become painful and frustrating. This highlights the need for assistive solution that can restore and reduce discomfort. When using a standard key, the motion typically involves a lateral pinch grip between the thumb and the index finger. This type of grip concentrates its force directly on the CMC joint. Additionally, because the key is small, the lever arm is short, which means a higher force is required to generate the necessary torque to turn the lock. The combination of high force and concentrated loading leads to increased stress on the joint, making the task painful and difficult for individuals with osteoarthritis. With ergonomic handle, the idea is to shift from a pinch grip to a full hand power grip. A larger handle allows the user to use their entire hand instead of just the thumb and index finger, and this distributes the force across multiple fingers and the palm, reducing the load on the thumb joint. At the same time, increasing the size of the handle increases the lever arm, which reduces the amount of force required to generate the torque. Now, looking at the biomechanical rationale, the design is based on a simple but important mechanical principle, which is torque. Torque is defined as a product of force and lever arm distance. For a given torque required to turn a lock, if lever arm is increased, the required force decreases proportionally. And by increasing the effective radius of rotation through a larger handle, the stress on the thumb joint is reduced. This makes the motion easier and less painful for users. The main objective of this design is to reduce the load on the CMC joint by enabling a power grip instead of a pinch grip. The handle dimensions were selected by significantly increasing the lever arm while still remaining portable. An ergonomic shape was used to naturally fit the hand and improve comfort during use. Additionally, the design also includes a key attachment mechanism to ensure stability during rotation. The device is also intended to be lightweight, low cost, and easy to manufacture using 3D printing, making it accessible for a wide range of users. This slide shows the SolidWorks model of the key holder along with its main dimension. The overall length of the handle is 115 mm, which helps increase the lever arm significantly compared to a standard key. The shape also includes an hourglass profile that allows for a natural finger placement, and a thumb rest is also incorporated to guide proper hand positioning, which improves control. And the key slot is designed to securely hold the standard key and prevent rotation or slipping during use. The hourglass shape creates two rounded regions for the finger and palm, allowing a comfortable grip. The curved top surface promotes a more natural wrist position, reducing strain during use. And smooth fillets are also applied throughout the design to eliminate sharp edges and pressure points. The key is a cross-slot mechanism, ensuring that the key remains firmly in place during rotation. And overall, the design balances ergonomics, usability, and manufacturability, which was the goal for this design. A physical prototype of the design was created using PETG material through FDM 3D printing. PETG was selected because it provides a good balance of strength, flexibility, and durability. The printed model successfully accommodates a standard house key, and the handle feels stable and comfortable during use. The size and shape allows for full hand grip, which aligns with the design objective. In this first demonstration, I'm showing that the design is compatible with a standard house key, and the key can be easily inserted into the slot, allowing the design to be used directly without any modification. And it is important to note that this design is specifically intended for flat, standard house key and is not compatible with car keys, which have different shape and electronic components. And this ensures that the device remains simple, practical, and focused on common everyday use. In the second video, the standard house key is inserted into the cross-slot mechanism, which securely holds the key in place and prevents any slippage during use. Once inserted, the handle is held using a full hand power grip instead of a lateral pinch. The hourglass shape allows the finger and palm to naturally wrap around the handle, while the smooth edges improve comfort and eliminates pressure points. The thumb rest helps guide proper hand placement and supports a more naturally wrist position. In the final demonstration, the standard house key is inserted into the lock, and the ergonomic handle is attached through the cross slot. The handle is then rotated to unlock and open the door. Here, the full hand grip provides better control and requires less effort compared to a standard key alone. Because the handle increases the lever arm, the torque can be generated with a lower applied force. And this reduces stress on the thumb joint and minimizes a need for a pinch grip. Overall, this demonstration shows how the design improves usability and comfort. This table compares the proposed design with standard keys and existing key holder. Unlike standard keys, this design enables a power grip and significantly reduces joint load. Compared to existing solution, it offers a more customized ergonomic shape and improved key stability. It also maintains a low cost and high portability due to its simple 3D printed design. In conclusion, an ergonomic key holder was designed and prototyped to address challenges faced by individuals with thumb CMC osteoarthritis. And by increasing the lever arm and enabling a power grip, the design reduces stress on the thumb joint. The device is simple, cost-effective, and practical for everyday use. And for future work, the design can be further improved through user testing and feedback, and different sizes and shapes can be accommodated for different hand sizes. and additional materials can be explored to improve grip and durability. And testing could also be conducted to measure force reduction and probably validate performance more accurately. This slide shows the SolidWorks model of the ergonomic key holder from multiple perspectives. On the right, you can see the angled side view, which highlights the curved top surface and the thumb rest. This feature allows to guide the hand into the natural position and improves comfort during use. In the center, the front view clearly shows the hourglass-shaped profile, and this shape is designed to allow the finger and palm to wrap around the handle naturally, enabling a full hand power grip instead of a pinch grip. And on the right, the isometric view shows how a standard key is inserted into the base of the design, and the cross-slot mechanism securely holds the key and prevents any rotation or slippage during use. Overall, this design focuses on ergonomic stability and ease of use, which is also being simple to manufacture using 3D printing. These are the references used for the project. For your time and attention, and I hope this project demonstrated the design and how it can improve everyday functionality for individuals with CMC osteoarthritis.